Hello everyone, I am David Deden, Creative Director at Asobo Studio, and I'm super proud and happy to talk about weather today for the new flight simulator. There is 5 important things we want to cover today about this new atmospheric engine in order to unify the rendering of the sky in the simulation. Everything related to the weather special effect, also the new day and night cycle, the volumetric clouds, and the live real-world weather implemented natively in the game. So, to start with the new atmospheric simulation, we had to completely restart from scratch this aspect of the sim, because we really wanted the lighting of the world to be as realistic as possible and to take advantage of new techniques coming from the video game industry to make this as best and as realistic as possible. So, in this case, the new scattering systems allows us to unify all the different sources of light and to render all of them all together. Typically, the sunlight, the moonlight, the starlight, the city lights, all of those things are informed by the air density, by the humidity of the air, even sometimes by the pollution. And all those different layers of atmosphere are taken in account to scatter all the photons coming from those different light sources. So the shadows have also been really improved. Now the mountain casts shadow on the clouds, the clouds cast shadow on the mountains, the clouds cast shadow on themselves, and all of those different layers of clouds cast shadow on the ground, which gives a general feeling of realism which is never seen before. So now, what about the new weather special effect? We've got now a fully volumetric 3D rain natively in the game. We also have a volumetric rainbow scattering. It's really based on what would happen in real life. If you have the right context, the right level of humidity, typically rain, and the right angle, you will see a rainbow where you would see it in real life. At the level where actually, as in real life, most of the time there is an echo to the first rainbow, and you can see it in game. You can see the echo of the first rainbow propagating in the atmosphere because it's a scattering calculation, so it works as in real life. So the rain impacts also the cockpit itself. Each water drop on the windshield is informed by the speed of the plane or the thrust of the engine. Depending on this, you will see each drop of water being stretched on the windshield, which is pretty neat. We also have a fully volumetric fog. We also have the icing, depending on the real-life parameters and context. So we will see the ice propagating on the wing, and with all the systems that allows the pilot to de-ice the wing. This clip is cool because it shows what I was talking about. You can see this cloud in the middle of the picture, which is lit directly by the sun because there is a hole in the cloud ceiling, and the other clouds all around are darker. And it works also for the rain that you can see under the cloud, which is lit directly by the sun too. So we can see the nice movement of the rain. So it's a time lapse, so it has been slightly accelerated in order to demonstrate what I was talking about. Here you can see the rainbow, and if you look at it closely, you can see the echo of this rainbow behind it, again, because it's really based on physical calculation. Here you can see the rain impact the cockpit rendering and typically the way the water propagates on the windshield itself. And you can see that depending on the speed, the drop of water will be stretched in the direction of the wind, which is pretty neat. So we have also improved the night engine. So now we are talking about a fully yearly based day and night cycle. What it means is that the position of the sun will be really informed by the moment of the year. Summer, the sun will be higher in the atmosphere in the north hemisphere, obviously, and it will be lower during the winter. But it's the same thing for the position of the moon, depending on the moment of the year or the month. Same thing for the stars, which will have their accurate position in the sky. We have also completely revamped the lights on the ground. So the city lights, the road lights, the runway lights, or the airport lights in general, all those lights will also inform the rendering. You can see the clouds being lit by the city by night. And it allows, as a result, VFR navigation by night, which is pretty cool. All the reflection also are taken in account. So you will see all those lights reflect on the water, for example. which is also rendered as any layer of the atmosphere. It sounds weird, but it's actually the case. So you can see on those videos that during a dark day, the water will be super dark and the reflection of the buildings are really dark. And in a bright day, you can see that suddenly, in this case, the Seattle Bay is pretty colorful, and you can see that the ocean now is at the same spot, much more blue due to the color of the sky and the reflection of the building themselves. It's much more colorful too. So now a few words about the volumetric clouds. To us, they are a little bit the star of the show, because obviously they are super important during a flight. They are generated based on 32 layers from sea level to high altitude. Each of those layers are informed by fuzziness, density, cloud shape, and all those clouds can be seen from any angle. There is no billboard effect. It's truly fully volumetric. They are not only visible from any angle, they are also informed during their life by the updraft, the wind, their dissolution, their formation, that you can see if you observe them exactly like it would be in real life, informed by the real life weather. So it's really neat. Thanks to this system, we basically have a native support of all the cloud types. Depending of the width of the layer or the density of the layers, we can basically display any type of clouds thanks to this system, which is super cool. And we simulated this all around the globe, and the view distance is 600 kilometers, which is really important because especially when you fly in airliners, you can see them from very far, and we still have the same level of accuracy, which is really great. In this video, we can see that even inside the cloud, the density of the cloud can evolve, and that when we go under them, you can see that the clouds cast shadow on themselves. Those two layers of clouds also cast shadow on the ground. On this one, you can see how the updraft informed the formation of this storm. As a result, now I would like to show you this video where we can see the different type of preset we've got in the game. You can change them on the fly, from clear sky to broken sky to stormy weather to rain, etc. All those presets are accessible directly from the in-game interface. So I would like to show you now something pretty cool that you haven't seen before. Is the ability for the user to change seamlessly the time of the day just with this slider. It's real time, no loading, and it's really cool. Hope you enjoyed it. So now a few words about the live real world weather. Based on everything I've said so far on the weather system, the architecture of the rendering of the weather has been made in order to also be able to receive real-world data and to inject those data directly in the engine to represent the real world as close as the data we actually collect all around the world. Those data are somewhere around 60 different layers everywhere in the world. Each of those layers, again, define the level of humidity, density, fuzziness of the different clouds type. We inject that directly in the engine, and it gives us as a result exactly what we would observe in real life. If there is a cold front in real life or hot front in real life, a storm, if it rains somewhere, all of that will be directly injected into the engine and will reflect what happens in real life. So on top of the information related to the clouds themselves, there is also all the information related to pressure, to humidity, to temperatures, to wind gusts. So as a result, we have a native support of Jetstream, for example. So your navigation will be based on actual weather information that you will have to take in account, which is super important, typically for airliners, where the navigation is really based on the speed of the wind on higher altitude. So on this video, you can see a screenshot of a website with real-life data, how we put this in the menu of the game, and how you can actually see the exact same clouds in-game. So to conclude this video, there is 3 highlights. The fact that we have a full spectrum weather that you can edit on the fly, real-time, seamlessly. That we have a fully volumetric sky, and also that the live real-world weather data can be injected natively in the engine and gives you exactly what you would have in the real world. So I hope you've enjoyed this video. Thank you for watching. See you soon.